So, welcome students. We have completed DC motor interfacing with 8051 microcontroller in last sessions, and in that we have seen direction control of DC motor and speed control of DC motor with the help of 8051, and then I have explained you that how to do the acceleration control of DC motor with 8051 microcontroller. Now the next interfacing is stepper motor controller. As you must have studied stepper motor principle also. Now what is stepper motor? As the name suggests, it is not moving in the kind the DC motor moves. When you give the supply in one particular direction, DC motor moves in either in forward direction or in reverse direction continuously. But here stepper motor, as the name suggests, it moves one step. So what is the step angle for stepper motor? The angle of one step is 1.8 degrees. So it moves for one step and then it stops. So if you want to give the steps, if you want to move the stepper motor in continuous steps, you have to apply the pulses in sequence. Otherwise it will move for 1.8 degrees one step and then it will stop. So we will not go to the construction detail of stepper motor because you must have studied in electrical engineering course of your first year electrical engineering course, or maybe in some other subjects. Just to go with the interfacing techniques, prior to that we'll just go through that how is the electrical model of stepper motor looks like. Stepper motor generally consists of 4 coils. Coil 1, coil 2, and both the coils are connected with one common. Then coil 3 you have and coil 4 you have. To activate one step, to get one step from stepper motor, all these coils must be energized with the help of pulses. And once the coil 1 get one pulse, after finishing that coil 2 should get the pulse, and after finishing that coil 3 should get the pulse, and after finishing that coil 4 should get the pulse. So to talk about in waveforms, with the help of waveforms, suppose if you provide the activation to coil 1 as this particular duration, then after completion, after energizing coil 1, you have to energize coil 2, and with the same duration you will be applying the same pulse, you will be applying to coil 2. Now when you are applying the pulse to coil 2, that time coil 1 is deactivated. The pulse which is getting is coil 2. Now after completion of this pulse to coil 2, you have to move through coil 3. The coil 3 will also get the same pulse, and during that period coil 1, coil 2 and coil 4 will not be getting any activation. Then after coil 3 you have to go with coil 4. So when you start from this particular instant, your one step will be covered in this much duration. As long as all the coils are getting energized one by one, after completion of this coil 4 stage, the stepper motor will move for one step. So if you are giving the supply in this manner, coil 1, coil 2, coil 3 and coil 4, then the stepper motor will move in clockwise direction. But if you want to move stepper motor in anti-clockwise direction, you have to, if you want to move the stepper motor in anti-clockwise direction, then after coil 1, which coil should get energized? Coil 4. After coil 4, which coil should get energized? It is coil 3. And after coil 3, which coil should get energized? It is coil 2. So the sequence of pulses will be same, but after coil 1, coil 4 will be energized. Then after coil 4, coil 3 will be energized, and after coil 3, coil 2 will be energized. So again, when you start from this instant, when you complete this much, it will move for one step. So what is the principle? The principle is that all the 4 coils should get energized one after another, and when all the 4 coils are getting energized one after another, at the last coil, whenever it stops, it completes one step. So as you know that it depends upon how much time it takes to move in one step. Because suppose if it is x, if this is also x, this is also x, this is also x, then it will take time 4x, x plus x plus x plus x for one step rotation. But if you take this time some other time, if you are taking, let's say if it is x by 2, this time, if you reduce this time, then if you apply this type of pulses, let's say coil 1 is getting this much supply, coil 2 is getting this much, coil 3 is getting this much, and coil 4 is getting this much. So now what has happened? Previously it was covering the one step at this particular instant. Now when it will cover one step from this to this, so you have reduced the time. That means your stepper motor will move faster because your energizing period for each coil is lesser, and all the four coils will get all the four coils will be energized in shorter duration. So your first step will occur in shorter duration. Same is the case when you want to go with anti-clockwise direction. So this is all about the basic principle of stepper motor. Now with the help of 8051 microcontroller, what is our job? If you want to move the stepper motor clockwise rotation, or if you want to move the stepper motor in anti-clockwise direction, we have to apply this type of pulses subsequently to coil 1, coil 2, coil 3 and coil 4. And in next session we will talk about the half angle also, so that you will, instead of getting 1.8 degrees, you will get half angle rotation. And we'll see the program for direction control of stepper motor. Goodbye then. We'll continue with the next session. So we were discussing the sequencing of the supply given to the coil. Now if you are talking about clockwise direction, then coil 1 should get energized first, coil 2 then, coil 3 then, and then lastly coil 4 should get energized. So what is the signal sequencing? This is logic 1 and this is logic 0. So if you are giving, the first energization should be coil 1 should get 1, coil 2 should get 0, coil 3 should get 0, coil 4 should get 0. Then next coil 1 should get 0, coil 2 will get 1 and rest will get 0. Then after this sequencing, coils 1, 2 will get 0, coil 3 will get 1 and coil 4 will get 0. And lastly coil 0, coil 1, 2 and 3 will get 0, and then coil 4 will get 1. So after this again we have to go with this sequence 1 0 0 0 0 1 0 0 0 0 1 0 0 0 0 1. So this will cover one step. One point when you give this type of supply, so this will cover full step rotation. But if you want to give half step rotation with for stepper motor, then how should be our energization to the coils? Previously the very first step, coil 1 will get 1 0 0 0, which is same as this. But now next you should not give 0 1 0 0, but instead of that you should not disconnect the energization of coil 1 and you should apply the energization to coil 2 also. So to come to this particular step, it will take 2 steps. So if it is taking 2 steps, that means your angle step will reduced by half. So previously you are getting full step angle as 1.8 degrees. Now you will get half step angle of rotation, that is 0.9 degrees. So how should be your sequencing of energizing the pulses? 1 0 0 0. You will not disconnect coil 1. Coil 1 will be getting 1. Simultaneously coil 2 will also get 1. Then 0 0. Now next is 0 1 0 0. Then after that coil 2 will not get disconnected, but simultaneously coil 3 will get the energization. So this is 1, this is 1, this is 1, this is 1. Now here you are obtaining what we have done previously. With this particular sequencing we were getting 1.8 degrees full step, but now if we apply this type of pulses, so how your energization will look? Your energization will look like this. For half step rotation, my coil 1 is getting the supply, coil 1, then coil 1 will also get the supply, and coil 2 will also get the. So students, now we'll see interfacing of stepper motor with 8051 microcontroller. So in last session also for DC motor we have discussed that we cannot directly connect motor to port pins of 8051. We have to use, because the current capability of 8051 pins are not sufficient to drive the motor. So in between we have to use the motor driver IC, and we have seen this IC L293D, which enhance the current capability of this particular to supply to the motor to up to 600 milliampere. So because stepper motor is having 4 coils, we have to energize coil 1, coil 2, coil 3, coil 4. So we have to use all the 4 drivers of this particular IC: input 1, input 2, input 3 and input 4. And as we know that input 1, input 2 is having 1 enable, and input 2 and input 3 is also having input 4 is also having 1 enable. So both the enables will be given to plus 5 volt supply. Now input 1 is corresponding to output 1, input 2 is corresponding to output 2, input 3 is corresponding to output 3 and input 4 is corresponding to output 4. So whatever we want to give for coil 1 should be given at port 1.0. We are using port 1. You can use any port. Last time also we have discussed that at any port can be used and any pins can be used, but just to make the program easier we are using subsequent pins consecutively: 1.0, 1.1, 1.2 and 1.3. So this will be this whatever we apply over port 1.0 will go to coil 1. Port 1.1 will go connected to coil 2 through L293D. Port 1.2 is connected to coil 3, and this pin, port 1.3 pin, is connected through L293D to coil 4. Now we have to, for clockwise rotation, we have to apply the sequence of pulses like this. Coil 1 will get, this may be for some delay. You can write a delay program depending upon the manufacturer. Now stepper motor also, different manufacturers have given different specifications. So this delay will depend upon the timings provided in the manufacturer sheet. So you will write the program for delay program for this much period, and the same delay will be called for all the 4 coils. Now to move the motor in anti-clockwise direction, we have to go with, first here coil 1 was getting, then coil 2 was getting, coil 3 was getting, coil 4 was getting. So for clockwise direction the supply should get coil 1, 2, 3, 4, and for anti-clockwise direction the supply should go from coil 1 to coil 4, then 3 and then 2. So what we are trying to do, we are trying to control the direction of the stepper motor with the help of 8051 microcontroller. So with this particular configuration, with this particular hardware, now what we are doing, we are taking we are rotating the motor, stepper motor in clockwise direction, and we want to rotate the motor in anti-clockwise direction. So for that, to generate this particular sequence, we have to take some data in accumulator. Now you know that coil 1 is connected to port 1.0. So logically all the pins of port 1. Should get 0, and except port 1.0 should get 1. But still, instead of taking the count as 0, 1, we have taken the count as 11. Now why we have taken 11, that you will understand when we go through the program step by step. So this is this is the count to energize the coil. So here with the 11 is this pattern: 0, 0, 0, 1, 0, 0, 1. So port 1.0 is getting 1, and rest all, because we have not used these particular pins, that is 1, 2, 3, 4. Port 1.4 to port 1.7 we have not used. So whatever may be the supply at this particular end, we are not bothered about this. We are bothered about this sequencing. So with this pattern, coil 1 initially is getting 1. So this is in accumulator now. This count is in accumulator, yet it has not gone to the port. Then we have taken one counter. Why we have taken 4? Because we have to give the supply to 4 coils. So just to have that we have to give this particular supply to 4 coils, we have taken the counter as 4, because 4 coils are there, so 4. Now we have taken one check whether jump JNB means what? Jump if bit is not set. Which bit? 00 hex. You have taken one bit as a flag and you are checking whether if it is 0, if this bit is not 0, then you have to go to the anti-clockwise direction. But if this bit is set to 1, then you have to go to the next instruction. So this is just to change the direction. We have to use this bit as a flag. Now what we are doing, what is it there in accumulator? In accumulator we have 11 hex. So 11 hex will go to port 1. So this particular pattern is going to port 1. So port 1.0 is getting 1 with this particular pattern. Now you are applying delay. You are calling the delay which you have written somewhere else. We all know that how to write the delay program. So you are calling the subroutine or subroutine of delay. Now this delay means this much period is given to this, for coil 1 is energized with logic 1 for this much period. After that, what you are doing, your job is to give the energization or supply to coil 2, and that time no other coil should get the supply. So we can take some count in accumulator and we can put it onto the port 1, and we can simultaneously for 1 coil, for 2 coil, for 3 coil, for 4, all the 4 coils will give. But then that will take more instructions to execute, and it will take more time, it will take more memory. And because we have the logical instructions like rotate and other instructions, we should make efficient use of this particular instructions. So now you will understand that instead of taking 0 1 over here, why we have taken 11. So what is rotate left doing? Rotate left accumulator without carry. Now if you are rotating the accumulator left, initially it was 1 1. So when you are rotating the accumulator left, with first rotation with left, what is the pattern you are getting? You are getting this type of pattern 0 2 2. So now what is happened with one rotation? Now port 1.0 will get 0 and port 1.1 will get 1. We are not bothered about these pins. Port 1.3 will get 0, port 1.4 will get 0. So whatever we wanted, we have achieved that. For this particular period, for this particular step, only port 1.0, that is coil 1, was getting logic 1. And for next first rotation, now coil 0 is deactivated, coil 1 is deactivated and coil 2 is getting 1. So first rotation means you are getting the supply to coil 2. Now what you are doing, because you have all gone to the next coil, so you are decrementing the count which you have assigned for number of coils by 1. So R7 will be decremented by 1. Now R7 will become 3. And you will check whether it is 0 or not. So it is not 0. So where are you going? You are going to clockwise rotation location. What is this clockwise rotation telling you? Clockwise rotation is written over. You are going with the clockwise rotation, that is this is your clockwise rotation. So now which pattern has come into accumulator? Accumulator is containing now 0 2 2. So 0 2 2 pattern will go on to the port. So instead of getting coil 1 energized, now coil 2 will get energized. Again this is applied for certain delay, that is this much. The delay is called. and again you are rotating this accumulator by 1 to left. So what is the new pattern generated? New pattern generated is this 0, whatever may be this. This is 4. We are not bothered about this. So now coil 1 is not getting supply, coil 2 is not getting supply, coil 3 is getting supply, which we wanted. So we are checking, decrementing the count assigned for coil by 1, and we are checking whether the count has gone to 0 or not. So it has again not gone to 0. So we are again moving to the location clockwise rotation. So whatever the changed pattern will come into accumulator, and through accumulator it is going to the port 1. Again you are calling delay. So how many times you are doing this? You are doing this for 4 times. Why we are doing this for 4 times? Because we have to energize coil 1, 2, 3 and 4. So when we are doing this for 4 times, then when this has gone to 0, you will not go to decrementing, it will come down and S jump to stepper motor direction. What is this location stands for? This location is available over here. So again you will take this because this is over, this is exhausted. When you have taken 0, 1, 1 and 4 times rotation, this value has been changed. So this is after one step, this will give you one step. Then if you want subsequent steps in clockwise direction, again you have to go through this particular program. So when our first step is over, full step, that is of 1.8 degrees step, again you are going to this particular location. And in between, now this is for clockwise rotation. In between, suppose if you want to change the direction to anti-clockwise, then what is your job? Your job is to, instead of previously you were energizing coil 1, 2, 3, 4, now for anti-clockwise direction, you will energize, after coil 1, you will energize coil 4, then 3 and then 2. And this you are doing with the help of one particular bit. Suppose if in program initially the bit jump, if bit is not set. So not set, that means suppose if in program somewhere you have done this bit as 0, 0, then when you go through this particular 2 instructions, these are initialization instructions. Accumulator will get 1, 1, that is your initial count to energize coil 1, whether it is anti-clockwise, whether it is clockwise. First, coil 1 must be getting the supply. Coil 1 should get energized. So we are not going to change this pattern for whether it is clockwise direction or whether it is anti-clockwise direction. Again, whether it is clockwise or whether it is anti-clockwise, coils are 4. So we have to energize 4 coils. So this count is also not going to change. But by changing this particular bit status in somewhere else, what you are doing, you are changing the direction of the rotation of stepper motor to anti-clockwise. So if this bit is not set, then go to anti-clockwise direction. So suppose if this bit is not set, then where are you jumping? You are jumping to anti-clockwise rotation routine. Where is this location mentioned? This location is mentioned over here. So what you are taking now here, the count whatever is in accumulator, that count will come into port 1. So coil 1 will get the supply with this. But and again you are calling the delay. So delay is called coil 1 will get the supply for this much of period. So now one coil is over. Now what is your job? You are not moving in clockwise direction. You want to move in anti-clockwise direction. So here you were doing rotate left. So rotate left, we are giving you the sequence which is useful for coil 1, coil 2, coil 3 and coil 4. But to go for anti-clockwise direction, you are using rotate right. Rotate right, what rotate right will do? So we were at anti-clockwise rotation routine. So what we are doing in anti-clockwise rotation? In anti-clockwise rotation, it was here. Anti-clockwise rotation, ACLK RT, move P, A. So this 1, 1 will go on to the port 1. You are calling the delay. Now in anti-clockwise direction, after coil 1, where the supply should go? Supply should go to coil 4. So what we are doing? We are doing rotate right without carry. We are rotating the accumulator contents to right. So when we do this rotate right, what will be the next? What will be the sequence available? Sequence is available like this. So this is for coil 1. This was for coil 2, this was for coil 3, and this was for coil 4. So with one rotate, now after coil 1, which coil is getting energized? Coil 4 is getting energized. Then for next rotate, this will do for 4 times because our counter is 4. 4 coils are there. So for next rotate, right, coil 3 will get energized and rest coils will not get energized. And for next rotate, we'll get coil 2 energized. So for anti-clockwise direction, we wanted coil 1 first energized, then coil 4, then coil 3, and then coil 2. So this is the way you can control the direction of stepper motor. So I think this is clear to you. If you have any doubts, you can ask me in the next session. Go through this video, put down your doubts, and you can contact me on WhatsApp or maybe on some with email or something. And stay at home, stay safe. We can stay connected with this YouTube sessions on microcontroller ESC 604 microcontroller. Goodbye.